The coldest place on the moon may soon become one of the most valuable. NASA is studying how to turn lunar ice into usable oxygen, not just in tanks, but through a real pipeline running across the South Pole. If it works, it could support bases, landers, and future Mars missions. It sounds futuristic, but the idea comes from real NASA-backed lunar resource studies. The reason is simple. Oxygen is heavy, essential, and very expensive to launch from Earth. Rockets need huge amounts of oxygen as oxidizer. Astronauts also need it for breathing and habitat life support. Every kilogram sent to the moon costs fuel, money, and launch capacity. That makes long-term exploration much harder. NASA's Artemis program wants more than short visits. It aims for a lasting human presence on and around the moon. For that to work, the moon cannot depend on Earth for every basic supply. Some resources have to be made locally. That idea is called in situ resource utilization. In simple terms, use what is already there. The lunar South Pole is the best place to try. Some ridges get long periods of sunlight, which is great for solar power. Nearby crater floors stay in permanent darkness and may hold water ice that has survived for billions of years. Shackleton Crater is one of the most promising locations. It is deep, cold, and full of scientific interest. Robotic machines could scoop icy regolith from shadowed ground and feed it into processing units. The ice would be heated and separated. That gives oxygen for people and propellant, and hydrogen for future fuel systems. Making oxygen is only half the challenge. The next question is how to move it safely across rough lunar terrain. Tanks on rovers sound simple, but they are slow, power-hungry, and risky on steep crater routes. So engineers explored a smarter option. What if the moon had an oxygen pipeline, like an industrial site on Earth? In this concept, a gas line about 5 kilometers long would connect the oxygen plant to storage near a future base. Once installed, the line could move oxygen steadily, day after day, without constant rover traffic. Some studies suggest this kind of system could deliver around 10,000 kilograms of oxygen each year. That oxygen could support habitats, fuel cells, surface vehicles, and early propellant preparation for deeper missions. Building it will be extremely hard. Lunar dust is sharp, clingy, and tough on mechanical systems. Temperatures are brutal. Repair crews are far away, and everything must work in vacuum with very little room for error. That is why robots would likely do most of the work, grading the route, placing pipe sections, and sealing the joints. Parts of the line may be buried or shielded to protect them from temperature stress and tiny impacts. In the long term, the metal for those pipes might even come from lunar soil itself, not from Earth. If that happens, the moon stops being only a destination for astronauts. It becomes working infrastructure. That shift matters because local oxygen means lighter launches from Earth and more freedom to build bigger missions. The first lunar pipeline would not just support moon bases. It could become part of the supply chain that leads to Mars. The next giant leap may not be a single lander. It may be a quiet line of oxygen, flowing through the darkness and helping humanity